What if we refueled the Sun with Jupiter?
The concept of refueling the Sun with Jupiter is a fascinating thought experiment that delves into stellar physics, planetary science, and the fundamental processes driving our solar system. Both the Sun and Jupiter are immense celestial bodies, but their roles in the solar system are vastly different. The Sun, a massive star, powers our solar system with its energy through nuclear fusion, while Jupiter, the largest planet in our system, is a gas giant with its own set of characteristics. This exploration of refueling the Sun with Jupiter will consider the scientific feasibility, potential consequences, and theoretical implications of such an event. The Sun's energy generation. The Sun generates energy through nuclear fusion, a process occurring in its core where hydrogen atoms fuse to form helium, releasing immense amounts of energy in the process. This energy is what powers the Sun and provides the heat and light essential for life on Earth. The Sun's fusion process is governed by the principles of stellar physics, including the balance between gravitational forces and radiation pressure. The Sun is currently about halfway through its main sequence phase, where it primarily fuses hydrogen into helium. This phase is expected to last approximately 10 billion years, and the Sun is currently around 4.6 billion years old. Once it exhausts its hydrogen fuel, it will transition to the next stages of stellar evolution, eventually becoming a red giant before shedding its outer layers and becoming a white dwarf. Jupiter's composition and role. Jupiter is composed mostly of hydrogen and helium, similar to the Sun, though it does not undergo nuclear fusion. It's primarily a gas giant with a core that is believed to be rocky or metallic. The planet has a massive atmosphere, and its size and composition make it the most massive planet in our solar system. Despite its similarities to the Sun in terms of composition, Jupiter lacks the necessary conditions for sustained nuclear fusion. Jupiter's primary role in the solar system is as a giant gas planet with a significant gravitational influence. It plays a crucial role in shaping the orbits of other objects, including asteroids and comets, and helps to protect the inner planets from potential impacts by deflecting or capturing these bodies. Theoretical refueling process. To theoretically refuel the Sun with Jupiter, one would need to introduce Jupiter's mass into the Sun's core to replenish its hydrogen fuel. Here's a simplified overview of the theoretical process. Mass transfer feasibility. Jupiter has a mass of about 1.9 times 10 to the 27 kilograms, which is approximately 318 times the mass of Earth. The Sun, in contrast, has a mass of about 2 times 10 to the 30 kilograms. This means that Jupiter's mass is only a tiny fraction of the Sun's total mass, around 0.1%. While this addition would be insignificant in terms of the Sun's overall mass, it would still introduce a considerable amount of hydrogen into the Sun's core. Process of introduction. Refueling the Sun with Jupiter would require a mechanism to transport Jupiter's mass into the Sun's core. In reality, this would be impossible due to the immense distances and the energy required. However, for theoretical purposes, one might imagine a scenario where Jupiter's mass is slowly fed into the Sun's core over a long period. Stellar effects. Introducing additional hydrogen into the Sun's core could potentially extend its main sequence phase. The Sun's fusion rate would increase as more hydrogen becomes available for fusion, potentially increasing its luminosity and temperature temporarily. However, the impact would be minor compared to the Sun's total mass and the ongoing fusion process. Potential consequences: short-term effects. Increased luminosity. If Jupiter's mass were to be introduced into the Sun's core, the immediate effect would be an increase in fusion reactions, leading to a temporary rise in the Sun's luminosity. This increase would likely be small compared to the Sun's total output but could still have effects on the solar system's climate. Solar output variability. The Sun's output might become slightly more variable during the process as it adjusts to the new amount of hydrogen fuel. This variability could affect space weather and the solar wind but would not drastically alter the solar system's overall dynamics.
Long-term effects. Extended main sequence phase. Adding Jupiter's mass to the Sun would marginally extend its main sequence phase.
However, this extension would be on the order of millions of years, which is relatively minor compared to the Sun's remaining lifespan. Stellar evolution. The long-term evolutionary path of the Sun would remain largely unaffected by the addition of Jupiter's mass. The Sun would eventually exhaust its hydrogen and transition to the red giant phase as expected, regardless of the brief refueling. Systemic impact. Gravitational perturbations. The process of moving Jupiter into the Sun would have significant gravitational effects on the solar system. The disruption of Jupiter's orbit could destabilize the orbits of other planets and celestial bodies, potentially leading to changes in the solar system's architecture.
Jupiter's role. Losing Jupiter would alter the gravitational balance of the solar system.
Jupiter's absence could increase the likelihood of asteroid and comet impacts on the inner planets, as it plays a crucial role in capturing and deflecting these objects.
Theoretical implications. Scientific curiosity. This thought experiment highlights the intricate balance of stellar and planetary systems.
It underscores the complexity of stellar processes and the interconnectedness of celestial bodies in our solar system. Energy considerations. The idea of refueling a star with a planet's mass illustrates the challenges involved in energy management on a stellar scale. It emphasizes the scale of energy and matter required to influence stellar processes meaningfully.
Exploration of possibilities.
While purely theoretical, the concept of refueling the Sun with Jupiter encourages exploration of extreme scenarios in astrophysics. It stimulates discussions about stellar evolution, the limits of human technological capabilities, and the broader understanding of cosmic systems. Conclusion. Refueling the Sun with Jupiter is an intriguing thought experiment that delves into the boundaries of stellar physics and planetary science. While the practical execution of such an idea is beyond our current technological capabilities, exploring the theoretical implications provides valuable insights into the dynamics of our solar system and the processes governing stellar evolution. The notion underscores the balance and complexity inherent in cosmic systems and serves as a reminder of the vast scales and energies involved in celestial phenomena. Thank you for watching.